So, second video we're going to talk about for our chapter 3. This goes more with 3.2 in our big exponent loss section. We're talking about product rule of power. That's an F there. You guys know Mr. Banker has bad handwriting, so should be no surprise. Okay, so product rule of powers. Product rule of powers are things you really want to concentrate on in terms of understanding is, one, they have to have the same base to do a product rule of powers. If they don't have the same base, you can't do it, okay, because they're unrelated. Kind of think about like terms in a way. Okay, but if they do have the same base and you're multiplying, okay, you are going to add the exponents, okay? So that's the relationship. So if you have a to the m times a to the n, it's simply a to the m plus n. So you add the exponents. So the big deal here is, you may want to write, we want to add the exponents. That's the main concept. Okay, well, let's do a couple here. What we're talking about. So we have x to the fourth times x squared. Okay, so first thing, do they have the same base? Yes, we have x and x. So I simply go x to the 4 plus 2. Okay, so that gives me x to the 6. Now if you're saying, wait, this doesn't make any sense, we're multiplying them. Well, let me show you why. Since powers, exponents, are a multiplication property, then we need to add the exponents, because what we're doing is, if we have 4 x's, see, this right here signifies x4. We're timesing, so I still have a times sign, and 2 x's. This one is right there. Well, how many x's do I have? Well, I have 1, 2, 3, 4, 5, 6. So this is x to the 6th. So again, since exponents are a multiplication property, you're multiplying them by themselves. When you're putting another multiplication next to it, you're essentially just adding these together to make it a total of 6 times. Okay? So you're adding the exponents on the product rule of powers. Let's look at a couple more here. Okay, let's throw in a couple constants here. Okay, so I have negative 2, m3, m5. Well, first off, everything's written together. There's no sign. So you're like, well, what do I do? Well, remember, if you have a 2x, that means 2 times x. So these are all being multiplied. Okay, now the negative 2 is kind of on its own. It's a constant. There's no other 2's, so it's just going to stay negative 2. And then we have an m3 and m5. Again, they have the same base. So we're going to take their indexes, or exponents, and we're going to add them. So it's going to be m plus 3, or excuse me, 3 plus 5 for m8. m8. So negative 2, m8 there. Okay. All right, we're going to do 5 total here. Maybe 7 or 6. Okay, 3. So we have negative 3 y cubed, and then I have times 5x y4. Okay, so when you're dealing with a problem like this, it's important to identify what common bases you have. And I like to group them in terms of like terms. Now, you only have to worry about bases for stuff that has an exponent. So, for example, we have 2 y's here. Okay, there's only one x, so that's not going to change. And then we have a negative 3 and a 5. Those will change because they are numbers. We can still simply multiply negative 3 and 5, okay, because they don't have an exponent. So they're kind of like, just think normal. It's not confusing. It's just they are numbers. So if I come here, like this is what it's going to be. It's going to be negative 3 times 5. Then we have x, and then we have y3 and y4. Okay, so I've kind of grouped them in terms of like terms, if you will. I got my numbers, my x by itself, and my y's. Okay, so now let's put those together. Negative 3 times 5, negative 15. X, there's nothing else. I have to leave it x. Y3 and y4 applies to our rule. Okay, 3 plus 4, I get y7. Okay, I get y7 there. Okay, let's go and do one more here, a couple more. All right, so our next one we're going to look at, we're going to do 6x5 times 3x5 times x. Okay, so again, I have my x's, I have my numbers. My numbers don't have exponents, so I can multiply them. Okay, so my numbers, 6 times 3, 18. My x's, I have an x5, an x5, if there's no x, if it doesn't have an exponent up there, it's a 1 to us. Okay, it's a 1. So that's going to be x11. 5 plus 5 is 10, plus 1 is 11. 18x11. All right, two more. This one's a good one here. A lot of people mess up on this one. 3 cubed, or 3 to the third, times 3 to the fourth. Okay, when you're doing these, since they have exponents, okay, we cannot multiply the 3's. Okay, we can't multiply the 3's, and this is why. Because we know from just doing our rule, do they have the same base? Yes. Do they have indexes? Yes. We should get 3 to the 7th, and we do, and that's correct. Now, the reason it's not, okay, this is not right, 9 to the 7th, is because we need to think about this as, look, 3 times 3 to the third, that means I have 3 3's. 3 to the fourth, that means I have 4 3's. Okay, we don't have 7 9's. We have 7 3's. Okay, so that's where the difference is there. Okay, so do not multiply the bases. Okay, bases stay the same. That's why when we come up here with our x's, okay, our x's, that's still an x. It's not like an x, 2x, it's not a 3x, it's just x. Okay, and our last example here for this quick video, I have 2 squared times 2 to the 5th times 3 cubed times 3. Okay, so here they mixed it up a little bit. They gave you two different sets of numbers with same basis. I have 2's, I have 3's. Okay, we talked about earlier, if the 3 right here doesn't have an exponent, we assume it's a 1, or we know it's a 1, I guess you want to assume. Okay, remember, we do not multiply the bases here. We'll not have 4 to the 7th. That is not possible. It's going to be 2 to the 7th for this chunk. Okay, and then for my 3 chunk, it's going to be 3 to the 4th. And it just stays that way. Okay, now you can evaluate that because they are numbers, so you could plug that in your calculator and get the big number that it's going to be. But I'll leave that to you. The main point here is you keep, since there's different bases, they're going to be different parts. You have to have 2 different parts for 2 different bases. Remember, add the exponents. That's this lesson's main concept. Product of powers, add the exponents. All right, thanks for watching.